I guess let's get started. So we'll finish chapter 8. I think it's 8.8. And then we'll start chapter 9. And we'll stop there. And I'm almost done with your test. It should be ready by, I think, tomorrow night.
Did you post the notes from the last segment?
I thought I did. Did I not send it?
No, I see 8.4. That's the last I've seen.
Let me check. Maybe I scanned it and forgot to send it or something. 8.4 is the last one I sent?
Yes, sir.
Well, after that was, where is it? Yeah, I only have 8.4.
Because I got some of the 8.5, but I had stopped to pay attention to some stuff, and I missed some stuff that we were talking about.
Oh, 8. The last thing we did was 8.4. I don't think we did 8.5, did we? What was 8.5?
8.5 was
Yeah, last thing we did was partial fractions. It's 8.4.
Okay, so we don't have to worry about 8.5 then.
What is 8.5 on the homework?
8.5 was
Let me check.
is partial fractions.
Oh yeah, that's what we did last time. So I guess what we did last time was 8.5.
Yeah.
8.4 was I think I just numbered them wrong. Okay. But we already talked about 8.5, 8.4, 8.1, 8.2.
Yeah, you just
8,
I was just posted 8.5 up. That's why I was asking, because I look at 8.4. I'll look at them again.
Yeah, 8. When you look at the 8.4, it's going to be partial fractions.
Okay. So
yeah, there's nothing after that. We haven't gone past that. I just labeled it wrong when I emailed it.
Okay, so we don't have to worry about trig subs.
Trig sub, we did that a couple, I think a week before, the day before, the class before that.
Okay.
Yeah, we already did trig sub.
Okay, and then we did partial fractions last week. Okay. All right, I'm sorry about that.
Did you find them?
I'll look for them. I don't want to hold up the class too long.
Yeah, just let me know if there's anything missing. We did cover it, but if there's a file missing, let me know.
Yeah, that's the only file I haven't found. I'll look at it.
Yeah, it might just be named wrong, so double check.
Okay.
Okay, so we are going to, yeah, so we're doing improper integrals. So basically, when you integrate with infinity, you need to have a special notation. Honestly, this is more about notation than it is about anything new. So if you remember limits, then this is nothing new. If you don't remember limits, then it might be a little bit more difficult. So definition. Yeah. So if f is continuous, on the interval a to b, and absolute value of f of x goes to infinity as x approaches b from the right, or sorry, from the left, we define the improper integral of f on AB by the following. The integral from a to b of f of x dx is equal to the limit as I guess I'll use this notation. R approaches b from the left from a to b f of x dx. Similarly, if f is continuous on AB and absolute value f of x goes to infinity as x approaches a from the right, we define the improper integral a to b of f of x dx as the limit as r approaches a from the right f of oops, got my number symbol of f of x dx. In either case, though, if the limit exists, and equals some finite value, call it L, we say that the improper integral converges to L. If the limit does not exist, we say it diverges. All right, so it's an example. So this is why this is necessary. The integral from 0 to 1 of dx over cube root x. You see how I can't plug in 0, right? So we have to use a limit. So we use a special notation because this is improper. So we know that the function cube root x will go to infinity as x approaches 0 from the right. And if you remember what that looks like, we should look at a graph, right? Okay. So let's say f of x is equal to 1 over cube root to do it. Nope. Oh, well, I'll do it the other way. I'll leave it as 1/3 because I forget the command for cube root. So as we approach 0 from the right side, right? Notice how it shoots off to infinity. I can't plug in 0, but the limit would be from the right, infinity. From the left, it is negative infinity. The limit does not exist at 0, but it does exist from left and from the right and from the left. Right? This is negative infinity from the left, positive infinity from the right. Okay? And that's what we said just now on the paper. This goes to infinity as 0 approaches 0 from the right. All right. So we'll use a notation, right? So this will equal the limit as, I will say b approaches 0 from the right of the integral b to 1 dx over cube root x. So that will equal the limit as b approaches 0 from the right of what? That would be negative 1/3 plus 1 would be x to the 2/3 over 2/3, right? From b to 1. So that will equal the limit of 3/2 x to the 2/3 as b approaches 0 from the right from b to 1. So I can't write infinity or 0 in these locations if it's not defined, especially since infinity is not a number. So if you see an infinity in there somewhere, you need to change it. So now we do the actual evaluation part. So we're going to have the limit as b approaches 0 from the right of, plug in the 1, that would be 3/2 times 1 to the 2/3 minus 3/2 times b. So take your limit. This will go to 0, right? Leaving you 3/2. So this converges to 3/2. The whole point of this is to not use values that are not defined. But you can see though, when we integrated, you could use it, right? But we still write the notation limit because we don't want to take the limit until we're ready. Any questions on number 1?
So then we just like for the answer and everything, I get that, but that means like the b will be just be 0 then, like you said.
Yeah, you just, when you take the limit, when you finally do the limit, right, you plug it in or you allow the function to approach it and you see what happens. In this case, it was okay to plug it in, so you just do that.
Okay, thank you.
Will the constant always be 0?
No. It could be infinity, it could be 2, could be, I don't know, whatever. Okay. We haven't reviewed for test 3, have we? Can't remember.
No, we have not.
Okay. All right then. So maybe we'll finish this section and start reviewing. I think I said the test is on Monday, right? Next Monday.
I think
Yeah.
so, yeah.
That's what you had said. The 26th.
Okay. So yeah, we'll finish up chapter 8 today, and then next time we'll start chapter 9. All right, so this one is the same deal. You can't plug in 0, so we have to use this notation. So as the limit as b approaches 0 from the right, and then we replace the 0 with a b there. And then we integrate, and we get b to 2. Oh, sorry. Go ahead and integrate now, I guess. So that will be the limit as b approaches 0 from the right of, that'll be -2, add 1, -3, add 1 will be -2, so that'll be 1 over 2x squared from b to 2. So that will be the limit as b approaches 0 from 1 over 2 times 2 squared minus 1 over 2 times b squared.
Professor, I have a question. So
Mhm.
equal, can this line, the last line, can you tell me how to get the first part of it? The
Here?
limit, yeah, how you get this?
Oh, okay. Yeah, I'm sure that works. So basically you have -2, right? You bring up the 2 and take out the half,
Lower down, please.
right?
Okay, yes, the integration, but did we substitute by 0 or anything, or we didn't substitute yet?
No, we just did the power rule. Just integrate it.
Oh, okay, I'm just get confused. Yes, I know
Yeah,
the
so
power rule.
okay. So you see
Thank
how we
you.
got here, right?
Yes, got you.
Okay. Let's make sure there was no 2 yet. All right. So then we take the limit, right? So that will be 1 over 4 times 2 is 8, 0. That'll be, well, actually, yeah. What happens to this when I let b go to 0?
Because 1.
It's on the bottom.
Infinity is 1 over 0 is infinity, right?
Yeah, so there's going to be an infinite value here. This is
Undefined.
infinity, and that's a number, so also this should be negative, by the way. I forgot the minus.
It'd be divergent.
That'd be plus. Yeah, this is going to diverge, so you're going to get negative Yeah, so basically think of this as a number plus an infinite concept. So of course this will be infinity, right? So this will be, this diverges. So it did not converge to a value, so you just say the integral diverged. There's an infinite area, so it never closed off.
But don't we have 1 over infinity, which would approach 0?
Oh yeah, 1
As-
over 0. Right, I forget.
Well, as it approaches 1 over 0, wouldn't that make the whole number come out to 0? Because it's getting closer and closer and closer to 0, rather
Well,
than
let's
infinity.
look at it. Let's look at the graph and see what exactly is happening as we approach it. If it was infinity, then I would say, yeah, it is going to 0. But since it's not, let me share the screen. So, yeah, we have to think about these things, right? So we have what, square, and we have the 2 in front, and we're saying that this value is going to 0. So as the function approaches as the x values approach 0 from the right, what happens to the function? Right, it shoots off. So as I get closer to 0, it gets larger and larger. So it never gets there. So whenever you have a division by 0, you're going to have either either the function going to infinity or negative infinity, depending what kind of function it is. But either way, if you add a negative number, right, it's still infinity, so it makes no difference. But if x is approaching infinity, then we'd be going this direction, right? So then you would say the function goes to 0. Back in when we did limits back in the day, Cal 1.
Okay.
So yeah, we should keep an eye out for that too. So if it's an infinite, if b is going to infinity, then we'll see those scenarios. Now let's see the next question here. All right. The next idea just allows you to separate improper values. So suppose that f is continuous on the interval AB, except at some C, an element of AB. And absolute value of f of x is going to infinity as x goes to C. The integral is improper, and we define it as the following. Okay. And so basically, in case this doesn't make sense, what I'm saying is you have a function that's somewhere between, that is continuous in some interval a to b, but somewhere in that AB, there's a C that doesn't work, meaning it causes like division by 0 or it's infinite or whatever. If that happens, so if you know there's a value within the interval then you got to break it up and rewrite the improper integral like so. So you would say from a to b, the function is defined as a to c of f of x dx plus the integral from c to b. So you break it up in portions. Okay, so if both integrals a to c f of x dx it'll be smeared everything. Okay. So both of these converge to an L1 and L2 respectively, then we say that the improper integral from the original a to b of f of x dx also converges. If one or the other diverges, then the original diverges. Just gonna paraphrase there. Does that make sense? So if they both have to converge in order for the original to converge. If one of them diverges, then the whole thing is divergent. You leave it alone. Okay. There's no point in doing both. If one of them goes to infinity, you would stop. Okay. So let me, that's an example where you have that kind of scenario. So check this one out. It's -1 to 2 of dx over x cubed. So you know that 0 is not allowed, right? But this interval includes 0. So the function 1 over x cubed goes to infinity when you approach as x goes to the positive side, 0, and goes to negative infinity as x approaches 0 from the negative side. Okay, so just break it up into pieces. So we know 0 is a problem. So you write it this way, -1 to 0, dx over x cubed plus 0 to 2 of dx over x cubed. But this is improper because 0 is not allowed, so you rewrite it with the limits. So you say limit as b1 approaches 0 from the left for the first guy, -1 to b1 dx over x cubed plus, I gotta write the limit again. Plus the limit as b2 approaches 0 from the right, the integral b2, I mean, I guess I don't have to call it b2, but that's fine. Make a distinction here. So then you'll integrate both, and then we're going to get, actually, I think we did that one earlier, didn't we? Yeah. It is the exact same question. We show that this part diverges in last example. That doesn't matter how this does. Since this is divergent, the whole thing is divergent. So you say -1 to x cubed diverges. Are there any questions about that? Let's do one more and then we'll start thinking about review stuff. This one's an infinite limit. So the example is 1 to infinity. Of dx over x. So that is improper. So you say as b approaches infinity, with the integral 1 to b dx over x. The integral would be ln x, right? From, shit, you got to write limit. You have to write limit every time. One to b. So that would be, well, what happens when I plug in b into ln as b approaches infinity? Right, this is going to go to infinity, so this diverges. Any questions on that last example? So you won't be doing any new integrals. It'll be the same stuff you've done before. It's just that you have to deal with these values that are undefined or concepts like infinity. Okay, let's start the review, and then we'll call it a day. There is 1, 2, 3, 4, 5, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20 questions on the review. Actually, I will not have 20, I'm pretty sure, but I'll check. I'll check later. Let me share the screen with you. Here's the review. So they're all integrals. All of chapter 8 was integration, right? So let's figure it out. Do you see how to do number 1?
Limit.
Remember, this is all chapter 8 now. Could be 8.1, could be 8.2, could be any integration technique. Like, is it by parts work? Does U sub work? Does by partial fractions work? Does trig sub work? Is there a table that you can use? So these are all the things you need to be thinking about when you're doing these questions. What technique do I try? I currently don't know which technique is best yet. I'm going to try whatever. I'm going to try U sub because it looks like it could work. If not, I'm going to try something else. Probably by parts if that doesn't work. So review for exam 3, right? Yeah. Number 1, integral of 2x over square root x minus 4. All right. And see if U sub works. I don't know. I'm saying U should be this. Du would be dx, right?
Yep.
If I solve for x, because there's an x up there, x would be equal to what? U plus 4, right?
Yeah.
Okay. Does that help me? Let's find out. I'm gonna pull out the 2 because I don't want to deal with it right now. I'm gonna have U plus 4 on top over, I'm gonna change square root to 1/2 power, okay? Du.
How we get to there?
What's up?
How we get to there? Like, did we use U and du? Or?
Yeah, I replaced U down for the inside, right? That's this
Yes.
one. And I solve for x using my sub, right?
Yes.
So I replace x with this. Excuse me.
Got you.
So the x is replaced. So now I have nothing but u's. So now I'm going to see if this substitution is easier than the original. So this is just an idea I'm trying. I don't know for sure yet. But I think it looks like it's going to work. So u du over u to the 1/2 plus, I'm going to put the 2 on both because technically it is. 4 du over u to the 1/2. So you see how I separate the fraction, right? The u over this and the 4 over that. You guys follow me up to this point?
Yes.
Let me know if I lose you, because this is what the review is for, to ask questions. Because I already know how to do this. I need you to know how to do this. Okay. So notice how we have u divided by u/2, right? So you can divide that. Divide this, that will give you what? U to the 1/2, right? Do you agree?
Yes.
And then the other one, that's just simply 8 integral u to the negative half du. So it looks like u sub was the way to go for number 1. So that will give us 2u to the 3 halves over 3 halves plus 8 times u to the 1 half over 1 half plus c. Bring back the u as x. This will be 2 times x minus 4 to the 3 halves. Oops. Divide the 3 halves, that would be what? 4/3, right?
Yes.
Divide the half, that'll be 16u to the 1 half.
We lost the negative.
What's that?
Negative on the 1
Okay.
half.
What happened? What happened to the half? Is that what you're saying?
So the negative.
Yeah, the negative, I added 1 to it, so it became positive. Half.
Okay. That's all I was asking.
Gotcha. Okay. Now that's our answer. The multiple choice goes further. But if you give me this, I'm giving you 100% credit. And this is good enough, right? But you know how the back of the book where the homework likes to do a lot of fancy algebra to make their answers prettier? It doesn't mean they're more right. It just means they're pretty. Because you could technically do what? You could take out, just to be weird. I'm going to take out, let's see here.
Like 4.
I'm going to take out a 4 for sure. And I'm also going to take out an x minus 4 to the 1 half. So that will leave me with 1/3 times the factor out an x. That would be what? 2, 1. Yeah, be 1. Sorry, my mind went blank there. Plus 4, right? And then they go further and they say, you know what, I'm going to factor out 1/3 from everything. So they pull out 1/3 from everything, which gives you x minus 4 plus 12. And then they say, you know what, one last step, combine your like terms. That would be x minus 8. See how this is prettier, but this is good enough though, right? But this is what they have as an answer choice. So try not to focus too much on the answers, just show me your work, okay? The answer choices could mess with your head. Just trust yourself. Go with what makes sense, okay? Does that make sense? Look, let me show you. So there's the answer. But our first answer did not look like this at all, did it? So do not obsess about answer choices. Make sure your work is good. That's what matters. Any questions on number 1?
No.
Okay. Number 2, I don't think that's worth doing. Do you guys want to do this one? Or do you see how to do it? What's up?
I pretty understand that.
Yeah, I would say probably the next one then.
Next one. That next one looks kind of weird. Okay. Next one. Number 3. (3x minus 1) over square root 3x minus 1. Currently, I do not see a use of that will be helpful. Maybe separating the fractions might be best.
Is the lower part is not exactly half the upper part? Or that's out of.
Do you mean the square root doesn't go all the way, or what do you mean?
I mean, square root of 3x minus 1 is half of the 3x minus 1, or no?
Yeah, well, it is a difference of squares.
Okay.
So, maybe that will help. Because technically, right? This is square root 3x minus 1 times square root 3x plus 1 over square root 3x minus 1. So you could factor the top and cancel this, right?
Right. So end up with square root plus 1.
So now we have an easy integral. Yeah, good idea, man.
Yeah, I'm smarter than what I look.
You got it, man. All right, so yeah, integrate each piece and we're done. So this will be what? 3x to the 3/2, right? 2/3 plus x plus c. Let's get the step here. Do you guys see how we get there, or no? The hard part was this part, but do you see the next step?
Yeah, it's where you just took the radical and changed it to 1/2.
Yeah. Well, actually,
That's what I usually do.
hold on a second. Yeah, the answer choices have an X. At least I think it looks like it. Check this out. That looks like an X right there, right?
Yeah, there's an X.
But I don't see why you would have an X there. Maybe it's a typo. We'll come back to that later. All right, let's look at the next ones here. Number 4. This is going to be a by parts question, or you can use tabular method. Same thing. You guys see how to do this one, or do you want to do this one? 4 and 5 are the same deal.
They're the same as B, right? Or
They're both by parts.
oh, okay.
Let's do 4. It's a little shorter, but it's the same thing. So I'll use the formula, but if you want to use tabular method, that is totally fine. So I'm gonna let U equal the easy part. I'm gonna go ahead and pull out the 14. So I'm gonna let it be X. dV will be sine X dx. So du will be dx. V will be negative cosine, right? Yes, you agree with that?
Yeah.
Okay, let's do the formula. So remember, the integral of U dV is equal to U times V minus the integral of V du.
And, 14 use X.
Well, here we go. Just go ahead and do it, right? So UV multiplied together. So negative X cosine X minus the integral of V du. V is negative cosine. Du is dx. This becomes a plus, right? So integral of cosine is sine. So this will be simply negative X cosine X plus sine X plus C.
And I can also use the tabular method to solve this one as well. Either or. Right?
Either or, man. I don't have a problem with it. As long as you solve it and you show your work, you're good.
Okay.
Like the next one, number 5, I recommend the tabular method. On this one, either way, it's fine. But number 5 would suck to do. You'd have to do this twice, which is annoying. All right. So 4 and 5 is the same deal. Well, so is 6. Do you want to do 6, or do you see how to do this? Similar to 4, but we can do it if you want.
No.
Okay. Number 7. This one we got to use those trig and remember I wrote you those different cases, like if sine is odd or sine is even, you do different things. Do you guys remember that? Well, let's do it. So
Yeah,
5,
say that.
4 was, let me see, 4, 5, 6, 7. Yeah, that's right. 7. All right. Oh, by the way, I'm going to start tutoring. I don't know if I told you guys. Tomorrow from 6 to 10, Tuesday, Thursdays. So if you go to Math World, they're going to put a link for me as well. If you want to come to my class or whatever. You don't have to, just saying. You're welcome to. All right. Sine cubed 3x dx. Okay. All right, so I see a cube. So the idea is you want to kind of set it up to be a, what's the word? A U sub to make all the trig go away. The 3x, you can handle it. But if it bothers you, you could say that u is 3x, du is 3dx. So dx is du over 3, right? So we can start there. I'm not going to write the bounds because this is going to be there. But anyway, it said that when it's odd, you want to break a piece off.
Are you sharing your screen?
Oh shit, I'm still on the other screen. Thanks.
Thank you. Sorry.
No, I appreciate that. I forget. All right, so let me show you what I did. So I'm replacing the 3x with u just to make this look simpler. You don't have to do this, but I'm doing it just for you because I feel like I want to focus on this cube idea and I want this to be out of the way. Okay. And I'm going to break off a sign because that's what the rule said. So I'm saving this sign to be a du later. That's basically the idea. But since I already used u sub, I'm going to have to use a different letter. We'll use w, I guess. Okay. Well, before we do that, I'm going to pull out the third. And I'm going to replace sine squared with 1 minus cosine squared u times sine of u du. Okay. So now I can say, you know what? Let's let w, I guess, since I'm doing it twice, w equal cosine u. So dw is going to be negative sine, right? Du. So that means that I have the sine u du. I just need to get rid of that negative. So I'll just put the negative over here. Negative dw is sine u du. Okay. So this will be 1/3 times the integral of 1 minus w squared times dw negative. I'm going to put in front. I skipped a step. I put this negative in front of the dw over here. So now integrate this and you're done. And we got to go back to u and then go back to x. So that's why I don't like doing this right here, multiple subs, because it can get a little weird at the end, but during the work it looks prettier. So I don't know. I don't know if it's better or not, but here we are. All right, so the integral will be negative 1/3 times w minus w cubed over 3. Now I need to go back to u, so that will be negative 1/3. I'm going to distribute the third, get it over with. Cosine u minus cosine cubed u over 9. This will be plus. And then I'm going to go back to x, so this will be negative 1/3 cosine of 3x plus cosine cubed of 3x over 9 from 0 to pi thirds. All right. So this will become, that's running out of space here, negative 1/3. Go ahead and put that outside. Cosine. If I plug in pi thirds, that would turn into pi, correct? Cosine cubed pi minus. If I plug in 0, we will get 1. Yeah, I don't know if I should jam it in here, but
Don't we have the cosine cubed over 3?
yeah, there should be a 3 there. I'm just no longer liking this space. We're gonna do it on a different page. It's not. I don't want to skip steps just to save space. That's silly. But yeah, you're right. There should be a 3 down there if I factor a third. Okay. So negative 3 third, sorry, negative third cosine 3x plus 1/9, right? Cosine cubed 3x, is that right?
Yeah.
Okay. So now let's go ahead and use the whole page. Who cares? All right, so that'll be negative. We'll go ahead and leave the numbers in there this time. Cosine of pi plus 1/9 cosine cubed of pi minus negative 1/3 cosine of 0 plus 1/9 cosine cubed of 0, which will be, cosine of pi is negative 1, so that'll be third. Cosine pi is negative 1, cubed still negative 1, so minus 1/9. Minus minus, that'll be plus cosine 0, which is 1/3. Minus a 0, 1, so that'll be a 9th. Yeah. So that will be 2/3 minus 2/9, which is 6 4/9. Is that right? Yeah, let's take it out. 4/9.
Did you just drop the 3, the pi over 3?
The pi over 3 is going to cancel with the 3x that's inside.
Okay.
So let's skip that little step there. Do you see the 3 here, right?
So what you talking about?
All right, cool. All right, so that's it for this question. But the idea, I mean, all that other crap is stuff you already know, but the new integral idea was this. This first step right here is I break off a sign, and then I do a u, then I sub the cosine, because I know I have a sign waiting for me for du, or the d sub, I guess. Everything else is just basic integration, but that's the new technique we did. These first 2 lines right here, or 3 lines. That's the main idea from that section, 8.4. No, 8.3. 8.4 is trig sub. 8.5 is partial fractions. So to see this one's the same thing. You got to pick one of them to break off, and then you do your integral. So this question, and that question, which is question 7, 8, 9, is the same section. You just need to figure out, how do I factor a piece off in order to do the u sub. So for this one, it'll be similar to the last one. You're probably gonna use
6x.
yeah, I'll probably either do a power reducing on this one, or change it to 1 minus sign and multiply it times this guy, but save one of the signs. Or sorry, break off a sign and replace this, change this to sine squared. Yeah, that would work. You want to do this one, or do you see it?
Let's just leave it so I can practice it.
Okay. Tangent similar, but you're gonna have to use secant squared. That was the rule that I wrote for you guys. That was 7, 8, 9, 10. 10 is not too bad. So here they just tell you use any method. Looks like that's basic use of will do it. If you let u be signed, you'll have du up top. So you have du over u squared. So the integral would be u negative 1, which becomes negative cosecant. So that one's pretty easy. Any question on this guy? Do you see how to do these? Do this one and this one? You guys
Let's try
cool on which one?
the tangent square over cosine x.
And that is 11. The integral of tangent squared x dx is cosecant x. At the bottom there. Okay. Okay. Maybe this will work. All right, I'm not sure how to do this yet. I'm just gonna try stuff. So this is how I do these problems. I think this will work. I'm not gonna separate it, right? So that would be cosecant squared x over cosecant x minus dx minus cosecant x this reduces, so that'll be cosecant x dx minus,
1 over secant cosecant x.
yeah, 1 over cosecant is sine, isn't it?
Oh, yeah.
Yeah, there you go. So now I would say use your table, or is this an easy integral? This one's no big deal, right? That's just cosine. I believe this one's going to be negative ln cosine plus something weird like that. Yeah, it's in that one table. What the hell is that? Oh, here we go. Yeah, it was negative ln cosine.
Raise it up a little, please.
Yes. So that was from the table, but you're allowed to use some of the integral tables, but if you wanted to derive that, you would have to do by parts, and it would be kind of long. So if we bring something like this guy that I just looked up real quick, I'll show you. Like, this is basic integrals for sine, cosine. I don't mind if you put that on your formula sheet, like the basic ones. You don't really have to show work for basic cosine, sine, integral. Anyway. This question said solve it any way you want. So there could be a better way. Like technically, I'm thinking, now that I think about this, cosecant is sine, right? We said that. So isn't it technically sine squared x over cosine squared x times sine x dx? So there might be another trig identity to help us here. Maybe, but anyway, I'm not seeing another way, but I don't want to waste time thinking about it as much as I want to play with it. This is the next question. Okay, so number, whatever the hell this is, 12 and 13. This is going to be trig sub. You can tell right away when I see a square root in the bottom or the top, there's usually a good chance that it's going to be trig sub. Number 12 is very obvious because there's nothing else to deal with, right? And then I see a square minus a square, right? See that? That's a big hint.
Yeah.
Trig
A
sub.
minus B.
And there's another one. A squared minus B squared, right? Or U, I think we use U squared minus
U,
A
yes,
squared.
U.
But that is your hint. Because I'm not going to tell you how to solve them. As you can see on the instructions, it just says integrate, integrate. So you need to be able to figure out, okay, what technique do I use? So first part is get good at all the techniques, and then the second part is learn when to use them. You want to do 12 or 13?
13.
13? Okay. 14 is also the same trick sub. This is going to be the, what's it called? No, actually, this is easy. This is a basic U sub. These two are trick subs. 13. Yeah. Alrighty.
Would be x minus 3, x
Oh
plus
yeah, sorry, the wrong one. Let me change the camera thing too. There's no values, which is good. I don't like plugging in numbers. X squared minus 9 dx over x. Okay. So let me pull up my trig sub rules. Count two notes. 6, 4. No, that's partial fraction. Oh, here it is. Excuse me. So we have x squared minus 9. So it looks like we're going to be doing the A secant. So our u is x, our A is 3, right? Well, hold on. Yeah. So let x equal A sine, or A secant, sorry. So that'd be 3 secant theta dx will be derivative secant is 3 secant theta tangent theta, right? D theta. Alrighty. And then it says that u squared minus a squared is equal to a tangent theta or negative a tangent theta, depending on where the angle is. Okay. Depending that theta is between negative and 2. Okay.
Why we choose to go the route of substituting with secant and tan? Why we went to this route?
Oh, here, let me show you. So I'm looking at our notes that we wrote here. Right, we said if it's a number, or sorry, if it's a variable minus a number, which we have x squared minus 3 squared, right?
Yes.
We should use a secant. And if we use a secant, then this must be replaced by one of these.
Okay, got you.
Okay, and it all depends on the a, which we'll figure out later. All right. So here we go. Gonna build the triangle. I'm gonna put theta right there. So if I solve for secant, right, we get x over 3 equal to, let me switch back. X over 3 is equal to secant theta, correct? I divide by 3 here.
Yes.
So secant is 1 over cosine, right? So adjacent over hypotenuse. Yeah. So then this missing side will become the square root of x squared minus 9. Which is what the note said. We had that triangle. Okay, so here we go. So the top will be 3 secant theta d theta. Actually, I need to replace the x first. So that's our fraction, or the square root part, times 3 secant theta tangent theta d theta over 3 secant theta. Oh shit, I messed up. This is equal to 10, not secant. Sorry, I'm getting a little tired. So remember, the square root is equal to a10. So we have a 3 tangent theta up here. Okay. So now we can start canceling, integrating, doing identities and all that stuff. Okay.
Wouldn't the bottom be C? No.
So this will cancel with that, right? Leaving us with 3 tangent squared theta d theta. Tangent squared is the same as what? 1 minus secant squared, is that right? Oh, crap. Made a mistake on 11. Just realized it. Yeah. On your notes, I would disregard 11 because my Pythagorean was wrong. Sine squared theta plus cosine squared theta is equal to 1. But divided by cosine, this becomes a tangent plus 1 equal to secant squared, not cosecant. That would be 1 over cosine, which is secant. My bad. Dang it. So this would become secant squared theta minus 1 d theta, which gives you 3 integral of secant is a tangent, right? Minus theta plus c. Is that right? Yeah. So now replace everything using your triangles, and this will become 3 adjacent over hypotenuse, so that would be x squared over 9 over 3 minus theta, which is really just secant inverse. Yeah,
Can you put the sheet up a little bit?
sorry. Secant inverse of x over 3 plus c. Some of that scratch work. I'm trying to separate it because it looks kind of messy right now. Okay, so because it had a theta, I have to come back here and solve for theta, right? So secant inverse on both sides gives me solves for theta. So here it is. So the answer will be C. Yeah, that's what they got. Okay. Any questions on any of these steps?
I just got to practice this stuff.
Yeah, the trig sub for me was the hardest one. It took me a while to finally grasp it when I first did it. You just got to remember the definition of each function, and then you have to remember when do I use which one. And if you have the definitions and those notes, you should be able to set it up. $14. Let's go ahead and do this one really quick because it's short. All right. So basically all you do is let u equal, well, first rewrite it actually. This is just 1 plus 4t squared, right? dt. So let u equal 4t, so du is 4 dt. So du over 4 is equal to dt. So then we get 4 out here, du over 4 there, over 1 plus u squared, which gets me to the integral make sure that's right. Yeah, that looks right to me. Sorry, let's double check. So that will become 4 over 4 du over 1 plus u squared, which is the arctan, the arc tangent of u, which is actually 4t from -1 to 1. And then you just plug in your numbers. Yeah, that's about it. You would end up with 2 arc tan of 4.
Quick question.
Right.
I forgot how to get the arc tangent. I think that's the thing. I get everything else, but I'm just struggling how to get the arc tangent.
Oh, okay. Here, it's just this from the table. I just need to remember. Let me find it. Yes, this one here. This top one, well, actually, this one's better looking. So if you see a variable squared and a number squared, so we had 1, right, plus u squared. So it's automatically going to be arctan. You're just going to remember where the numbers go. But since ours was just a u because I did the sub, it's just going to be a 1 in front. So it becomes arctan. And then we bring the u back, which was 4t. Then we just evaluate. And that's it.
Okay, I get it now.
Yeah, make sure you have a small table of the basic integrals if you don't have them memorized.
I have a question. It's not related to the problem that we are doing. Can you go to the previous problem, the previous one, the one that's having the triangle? Yes. It's quite a dumb question, not related to the solution, but I want to know it for myself. So the problem is integration of square root x squared minus 9 over x. If I want to invert this fraction, like put the x at the top and the square root of x squared minus 9 at the bottom, should I put all to the power -1, the whole fraction to the power -1 to invert it, or there is no way to flip this denominator instead of numerator?
I mean, you would, if you flipped it, you'd have to write another power to unflip it because there's no equal side. So you can't, like, if you had two sides, if it was an equation, right, you can invert both sides, but we don't have two sides. So not really is my answer, but
yeah, I mean, if you put x as the top and the square root, is there is a way to put the x as the top, write the fraction in the other way, the x as the top and the x squared minus 9 as the bottom?
the only thing I could do is this 1 over x square root.
Ah, okay. Okay. The same thing. Yeah, okay. Got
But
it.
if you try to invert it, you'd have to do -1 and then again another 1, -1, because it's not supposed to be there, right?
Ah, okay. Okay.
So if you did double -1, that'd be a positive 1, but then you'd have your problem trapped inside the power.
Right. Thank you.
Yeah. I think we have, let me see, which time is it? Yeah, I don't think we have time to do another one. The partial fraction takes forever. So I can set them up for you. Let me show you. Well, first of all, the ones on the bottom, that's what we did today. The infinity stuff or numbers you can't use, right? This is the 8.8, the last three. These two is just partial fractions. So you're gonna have to factor and do the a over whatever. On this one, it'd be ax plus b over this guy, b over this guy, or c over that one, right? So I'll set up the first one. I don't remember what number this is anymore, but who cares? That'll be 2x squared plus x plus 1 over, it was nice enough and factored it for us. I like when they do that. Right, so you would set it up as the integral of a x plus b over the first one plus c over the last one here. And then you would start solving for a and b. So really what I would do is don't even write the integral or dx. Solve this partial fraction first. Right? Solve this first. Instead, so you would set it up, right? You would get 2x squared plus x plus 1 equal to x minus 5 times ax plus b plus c times x squared plus 3. I skipped all the algebra steps. And you could use the Heaviside method on this one because it's a little easier. Because there's only two pieces that are factored, right? Well, I don't think that would work actually. I could find C easily, but not, yeah, never mind what I said. Heaviside is not good for this one. But on the next problem, you first have to factor and then set it up like we did. Okay. So on this one, let me set it up for you. you'd have 5x plus 12 over x cubed plus 4x squared is what they gave us, plus 4x. If I factor the x out, we'd be left with x squared plus 4x plus 4, right? Which is going to be factored into x plus 2 squared, right? You agree with that factoring?
Yes. Yes.
Okay. So then we got to do one of the cases, which will be a over x plus b over x plus 2 plus c over x plus 2 squared. We count up to the power. Remember the repeated rules? Then we multiply both sides by LCD and we get to here. That was a step I skipped earlier. And we end up with a times x plus 2 squared plus b times x times x plus 2 plus bx. And then you do your nonsense. Okay?
Okay.
This one, on this one you can find, oh, it doesn't matter. Use whatever method you like to find ABC. All right, guys, cool. We're gonna stop here because these take forever, but I at least wanted you to set it up, show you how you set them up and then solve for ABC, okay? Then after that, you put it back into integral form and you integrate each fraction separately.
Mr. Gonzalez,
Mm-hmm.
when do you get the test results from the last test?
I should have them tomorrow for sure.
And you didn't post 8.5. It was just 8.4 section.
The what?
It didn't have 8.5 section. 8.5, the notes from last?
Yeah, the notes, yeah, that's what I'm saying. Here, let me show you. You have these, right? Right here.
Yes, I have those.
Yeah, this is 8.5.
No, I don't have these. These are the ones I don't have.
Oh, you don't?
No,
Okay.
ones I was
Because
looking
see,
for.
I wrote 8.4 by accident, but I didn't send you this one. That's what you're
No.
saying.
No, I didn't.
Okay.
I didn't at all.
Oh, okay. Gotcha. So that was the confusion. I named it wrong and never sent it.
I
Okay.
got 8.4, the last one, but not this one.
Okay. Let me send it right now. Okay. 8.